Hello students, good evening. Welcome to the session 7 of electrostatic potential and capacitors. In Canada, we'll look at the concept of dielectric substances. Okay, so dielectric substance and what are the things that we need to be looking at in terms of dielectric substance. அது நம்ம பார்க்க போறோம். அதுக்கப்புறம் we'll also start with the idea of the capacitors. ஏன்னா நம்ம ஆல்ரெடி பேசியிருக்கோம் கெப்பாசிட்டர்ஸோட இம்பார்ட்டன்ஸ் பற்றி. லைக் இஃப் யூ லுக் அட் மோஸ்ட் ஆஃப் த பாஸ்ட் இயர்ஸ், ரைட், இஃப் half the times we are getting questions on the electric potential and things like that, the other half times we'll get questions based on the capacitors. Okay va? So we'll start with the first, which is the dielectric materials. So what are dielectric materials? Already when we look at the substances, right, so we'll classify the substance as either conductors or insulators. So like this is how we tried classifying the substances, right? Conductor and the insulator. But if we try to dig little bit deep into this insulator, right, insulators will be consisting of two further types. One is which is made up of polar covalent materials. Second is the pure covalent. Okay, so polar covalent and pure covalent. But generally, broadly we can use the term dielectric materials. For both of them also we can use the term what? Dielectric materials. So what is the difference between a conductor and a dielectric material behavior? Like when we talk about the difference, right, we will try to see what is the difference when we are applying an electric field through the conductor or through the dielectric material. Inga paranga. So we are giving an external electric field E0. So one, we are seeing what will be the effect of this on the conductor. Second is what is the effect of the applied field on the dielectric material. Okay, so conductor la pathina already we discussed about it. Because of the applied electric field there will be charge redistribution. So in what is going to happen here? Charge redistribute out. Okay, so there will be what? Charge redistribution. Charge redistribution sonna the charges in a conductor are what? Free charges or mobile charges. So like if you are looking at the metallic conductor, right, what is going to happen? Adil irukra free electrons, right, they will move in a direction which is opposite to the electric field. So if our applied electric field is towards the right side, it is towards the right side, so electrons will move to the left. So on the left side we will get what? Accumulation of the negative charge. The right side, because the electrons are moving from the right side, so the right side you will be having what? Positive charge. Adanal you will get a induced electric field. So because in a ideal conductor we'll assume what? There are infinite number of free charges. So the charges will keep redistributing till this induced field is equal in terms of the applied field, till it balances. Direction wise pathina, what is it? Because the applied field is towards the right side, induced field eppadi irukum? It will be towards the left. It will be what? From the positive field eppadi irukum? From the positive side to negative side dana. So the induced field will be from right side to left side, opposite direction. So the redistribution of the free charges keep happening till the induced field is able to balance the applied field. Directions are opposite, right? So inside the net field will be what? 0. Why it will be 0? Because the net field means what? The applied field is E0 to the right side. Adilande we have to subtract the induced field which is towards the left side, because both the values are same, right? So the net field inside the conductor will become what? 0. And it is not going to take much time for this to happen. It will be taking very less amount of time, like less than a millisecond. This entire process will happen. Okay, wow. So this is what we observe. So in case of a conductor, right, so what are the observation points? One is inside the conductor net field will be 0. Adu eppadi 0 agum? Because the induced field will be balancing the applied field. Adukaprom in a conductor, right, the applied field will create what? Charge redistribution. applied field will creating what? Charge redistribution. Okay, charge redistribution sonna it will be because of what? It will be because of the free charges or mobile charges. The charge redistribution in a conductor, right, is because of what? It is because of the free charges or the mobile charges. Okay va? So this is about the story of the conductor which we are keeping in an electric field. Okay, அடுத்தது என்ன பாருங்க கீழ. What is the next diagram that we are having? The behavior of the dielectric substance. Okay, so dielectric substance பத்தி we will discuss about it, but இங்க என்னன்னா we will try to look at the observations first. See, observations என்ன வரும்னு பாருங்க. The observations will be, these are the general observations whenever we take a substance, like water ஆகட்டும் or whatever the substance, general substances we have, அப்படி எடுத்துட்டு we are keeping in an electric field வச்சுக்கோங்க. Then what is generally observed is the net field inside, right, will be less than E naught value. This is the first observation. அது ஏன் அப்படி ஆகும்னு சொல்லிட்டு we will discuss about it. But what is the first observation? Inside the dielectric material, net electric field will be less than E naught. It will not be zero. So E net will not be equal to zero. Zero agadu. It will be less than E naught. Less than E naught. So now what is the understanding that we will have? There must be some induced electric field which will be in opposite direction. Like in the conductor case madri inga enna opposite direction la irukum, but the value will not be equal to E naught. Adanal it will not be able to cancel it. So paranga, the net field, right, will be equal to what? E naught minus E induced. But here E induced value will be less than E naught. Okay va? Adanal enna, the net field will not become zero. Conductor case la net field is becoming what? Zero. But inga appadi kadiyadu. Net field will be having some value. Okay va? Adukaprom in case of the dielectric also, right, when we keep the dielectric in an electric field, what is observed is charge on the surface, charge accumulation, and the people are able to observe charge accumulation on the surface. Similar charge accumulation in case of a conductor eppadi parunga, if you are applying electric field to the right side, then an object oda right side la you will get the positive charge. Inge appadida object oda right side la we are getting what? Positive charge. Left side la we are getting negative charge. But the charge accumulated here, right, will be lesser than the charge that you see in case of the conductor. In a conductor we are having the charge redistribution, right? So we will have the induced electric field which will be able to simply balance the applied electric field. So that is why in this case, right, the charge accumulation will be what? In the higher magnitudes. But there will be charge accumulation. Similar method la irukum, like in the given case we are giving the electric field to the right side, means right side of the object will get the positive charge, left side of the object will get what? Negative charge. Okay va? But charge or the magnitudes, right, comparably it will be what? Lesser than the conductor case. This is the observation in case of the dielectric. Okay, இப்போ நம்ம என்ன பண்ண போறோம்னா we will look at why this thing is happening in a dielectric, because we are able to see what are the observations. First we are able to see what is the basic difference between the behavior of a conductor and behavior of a dielectric. So ஒரு electric field குள்ள place பண்ணா what is the difference between the two behaviors, அது நம்ம பார்த்திருக்கோம். Now we need to understand what is actually happening inside the dielectric substance, right? So dielectric substance and சொல்றதுக்கு பதிலா we are generally using this word as what? Polar covalent substance. We are generally using the word called as what? Polar covalent substance. Okay, so we will try to see what is the reason for the behavior of these polar covalent substances or dielectrics. But before we go and see the reason why the dielectric is behaving like that, right, first we will try to understand what is this polar covalent and pure covalent. Idella chemistry la varum. Like when you look at the nature of the chemical bonding, right, only very few chemical bonds are pure covalent, or we will also call them as what? Non-polar and sollala. What will be the bonds that will be pure covalent? The bonds that are between identical atoms. இங்க பாருங்க, in a H2 molecule, right, the bond is between the two hydrogen atoms. And the மாதிரி நீங்க நிறைய examples எடுக்கலாம். What is it? In a Cl2 there will be a bond between chlorine and chlorine. So these bonds, right, they are bonds between two identical atoms. So they will be what? Pure covalent or non-polar. Okay va? There can be also molecules which are non-polar. அது எப்படி வரும் பாருங்க. In case of CO2, right, look at this, it is a linear molecule. CO2 is a linear molecule. Each of the carbon oxygen bonds, right, each bond will be polar. அதுக்கு ஒரு dipole moment இருக்கும். Each bond will be what? Polar. But என்ன ஆயிட்டிருக்குன்னா, like the two bonds, right, will be exactly in opposite orientations. பாருங்க, like if you look at the dipole moments, right, the dipole moment will be generally from oxygen will be partially negative, carbon is partially positive. இங்க அப்படிதானா? Oxygen is partially negative, so negative to positive. இங்க பாருங்க, what is happening? The dipole moments will be cancelling each other. So அதனால CO2, the molecule totally becomes what? Non-polar. So what we can have when we talk about the polar versus non-polar, right? Non-polar and sonna, either you can have the bonds between two identical atoms, like in the H2 or Cl2 and the madri, or we can have molecules where the bonds may be polar, but overall molecule will have zero dipole moment. Overall molecule will be what? Having no polarity. அதுக்கு நிறைய examples இருக்கும், like you can take chemistry, you will study about lot of these examples, like BF3. அதில் என்ன ஆகும், like each of the boron fluorine bond will be what? Polar, but the dipole moments, right, இங்க பாருங்க, fluorine is what? Partially negative, boron is what? Partially positive. So dipole moment will be, all of them are about symmetric, so அதனால they will be cancelling each other. So the net dipole moment will be what? Zero. Net dipole moment of the BF3 molecule level, it will be what? Zero. So அந்த மாதிரி நிறைய example, CCl4. Okay, so many of the examples you can think about. So these type of substances, right, we call them as what? Non-polar. Okay, non-polar la we'll have either the pure covalent bonds and the மாதிரி இருக்கிற substances like H2Cl2, or we can also have what? The molecules like CO2, where the overall molecule will be non-polar. The polar substances, right, will be what? இங்க பாருங்க, HCl, இதில் என்ன? Chlorine is having partial negative, hydrogen is having partial positive, so there will be a dipole moment. Molecule kulla there will be dipole moment. அந்த மாதிரி இங்க பாருங்க, H2O also will have a dipole moment. So oxygen in the partial negative, each hydrogen partial positive. பாருங்க, so each bond will have dipole moment. So net dipole moment பார்த்தீங்கன்னா we'll have to add the dipole moments vectorially. ஏன்னா dipole moment is what? It's a vector quantity. அதனால we have to add them using the vector principles of addition. But H2O molecule also will have what? Dipole moment. So the polar substances in சொல்லலாம், what we can call them as polar substances. Polar substances, molecules will have net dipole moment. அதுதான் basic difference. Polar substances என்ன? அந்த individual molecules கூட there will be net dipole moment. Non-polar substances, non-polar substancesல இவங்க ஸ்பெஷல் கேட்டகரி என்ன? Pure covalent. Non-polarல special category is what? Pure covalent. Okay va? So non-polar substances will have zero dipole moment for the molecules. இங்க பாருங்க, அது இந்த H2 மாதிரி molecule ஆகலாம் or CO2. So H2 will take it as what? Pure covalent. CO2 will be what? The pure covalent கிடையாது, because the bonds will be what? Polar, but overall molecular dipole moment is zero. So that is why we call them as what? Non-polar. Okay va? So generally when we are looking at the substances, right, எப்படி நம்ம classify பண்ணலாம்? We can classify substances as what? Either polar substances or non-polar. So non-polar and சொன்னா what is it? Overall molecular dipole moment will be zero. அவ்வளவுதான். Polar and சொன்னா what is it? Overall molecules will be having dipole moment. So இப்போ நீங்க பாருங்க, if you look at substance, right, if you look at a substance, அதில் எத்தனை molecules இருக்கும்? There will be millions and millions of molecules, right? So overall if you see, for a polar covalent substance means அதோட individual particles ஆகட்டும் or the entities, right, molecules, they will have polarity or dipole moment. So each molecule you can take it like what? Or dipole மாதிரி. Each molecule you can take it like a dipole. Okay, so generally என்னன்னா all these dipoles, right, will be randomly distributed. So எப்படி general அதோட distribution எப்படி இருக்கும்? They will be randomly distributed. So random distribution means என்ன ஆகும் பாருங்க. So when the dipoles are randomly distributed, so இப்படி இந்த பக்கம் ஒரு plus வரும், இந்த பக்கம் minus, இந்த பக்கம் plus, இந்த பக்கம் minus, இந்த பக்கம் plus, random distribution. So random distribution என்ன வச்சுக்கோங்க. Then what happens? The overall the positive charge oda positioning and negative charge oda positioning, right, inga parunga. So from here we are getting a positive, adukku adjacent we are getting a negative, inga enadhu positive, adjacent negative. So apdi overall charge oda configuration will be what? The positive and negative, because they are in close proximity, right? Adanal what we can say? We can say that the net charge distribution will not be there. Adana net charge distribution will not be there. But sometimes we can have the dipoles which are aligned in a particular way, where you may get some kind of a charge alignment. So here if you see, right, most of these dipoles, they are keeping their positive charge and the bucket over the right side, which means what? The right side overall you will see the right side part, it will be what? Marginally in the bucket marginally positive. Okay va? So if you see marginally, it will be what? Positive. And left side la you will have what? Marginally negative. Okay, so inga the molecules and the electrons வெளியே வரது கிடையாது. So just the molecule itself, right, is having partial positive charge ஒரு சைடுல, partial negative charge ஒரு சைடுல. If they are aligning, right, you can see in some situations ஒரு பக்கம் என்ன வரும்? Marginal positive charge, இங்க ஒரு பக்கம் marginal negative charge. So generally when you look at the polar covalent substance, right, இப்படி தான் இருக்கும். Like either we will have random distribution, like இந்த மாதிரி. When there is a random distribution means what? The net charge distribution will not be there. Net charge distribution இருக்காது. ஏன்னா ஒரு டைபோலோட பாசிட்டிவ் சார்ஜ், அதுக்கு பக்கத்திலே you will have another dipole negative charge. So adanal the overall charge distribution will not be there. Sometimes we can have the dipoles which are oriented in a particular way. You will get one side, you will get a marginal positive charge, on side you will get marginal negative charge, but the chance for this to happen will be very less. Because even at room temperature, right, even at the room temperature, the thermal agitations, thermal agitations means what? Room temperature you will have what? The molecules having thermal agitations, right, means what? The movement of the molecules because of the temperature. Thermal agitations itself will be sufficient to create the randomness. So you will not be able to have a structured alignment of these dipoles. Okay, so even if there is an small alignment, right, it will be remaining for a small amount of time. Adukaprom it will again become random. Appadida. So one thing is because of the random distribution, right, inside the polar covalent substances, there will be no net charge distribution. Net charge distribution illanna, what is the outcome of this paranga? See, one side la you are having a positive charge, one side you are having negative charge vechukonga, then you will have net electric field that is developed. But on the madri illanna, then what is it meaning? It means that the field inside will be what? Zero. The field inside will be what? Zero. Okay, so correct example vechukonga. Here we are not talking about field created by somebody. So வெளியிலிருந்து whatever the field coming, we are not talking about that. நம்ம எதை பத்தி பேசுறோம்? We are talking about the field which is because of the alignment of the dipoles. Most of the cases we'll have a random alignment of the dipoles. அப்படி இருக்கிறதுனால we will not be having any charge distribution. So ஒரு பக்கம் பாசிட்டிவ் ஒரு பக்கம் நெகட்டிவ் அப்படி வராது. அப்படி வரலன்னா what is going to be the outcome of this? The field inside the material will be what? 0. Okay, so this is the not the external field. இது external field applied field கிடையாது. இது என்னது? This is the field which is inside the substance because of the dipoles. Okay va? But sometimes we can have some marginal alignment. அந்த மாதிரி marginal alignment இதை வச்சுக்கோங்க. Then what is going to happen? We may have some field. இப்போ ஒரு சைடில் ஒரு marginal positive charge, இன்னொரு சைடில் you are having a marginal negative charge. அப்படி இருந்தா then we may have some electric field. But அதோட value will be very small. The value of that will be what? Very, very small. And already நம்ம சொன்ன மாதிரி even the thermal agitations at the room temperature, right? They might just sufficiently create the randomness. அது இல்லாமல் இன்னொன்று பாயிண்ட் இருக்கு. If these dipoles are randomly distributed, so randomly distributed என்னது? They are distributed in various different directions. If you want to calculate what is the net dipole moment, so dipole moment என்னது? Vector தானா? So each of these molecules is like a dipole. எப்படி இருக்கு அதோட arrangement? They are in all different random directions. And it is not like we are having one molecule or two molecules. We are having like what? Millions and millions of molecules. So when you try to add up all the dipole moments, they are in different directions, right? The average rule says what? The net dipole moment will be 0. Average rule says what? Net dipole moment will be 0. Okay, so because of the random distribution of these dipoles inside the material, net field will be 0. And the madri net dipole moment also will be 0. Okay va? So this is what when you are just having the polar covalent substance. The substance ku mela we are not giving any field or anything. Adukku mela nama oru field create panna kediyadu. So just that substance adu mattum irukku vechukonga. Then that is what is the behavior going to be. Idukku appuram enna? If we are trying to apply an external field, so நம்ம ஒரு external field apply பண்ணா என்ன ஆகும் பாருங்க. See, remember already நம்ம இந்த கான்செப்ட் பத்தி பேசியிருக்கோம். Like if you have a dipole, you apply an electric field, then what is the least energy state of the dipole? The dipole oda energy எப்போ least ஆகும்? When the dipole is in the stable equilibrium position. Stable equilibrium position ன்னு சொன்னா என்னது? The dipole will be aligned in the direction of the applied field. அப்படிதானா? So இங்க பாருங்க, it is like what? Suddenly when you apply electric field E ன்னு வெச்சுக்கோங்க. So this is what? Applied field. இது applied field. Okay va? If you create an applied field, then all these dipoles are like present inside that electric field. And the electric field kulla irukra madri. Then what is going to happen? All of them they will try to inga parunga. So dipole direction ippadana from negative to positive. So all the dipoles are what? They are aligning. They are aligning in that stable equilibrium position. All of them are aligning in the stable equilibrium position. Okay va? So when they are aligning in the stable equilibrium position, paranga ennagu? We will now be able to see the net dipole moment. And here what is happening? All of them are like adding each other, right? So because of the external field, we will have a dipole moment inside this substance. Adukku nam enna? What is the word that we say? Induced dipole moment nu sollu. So what is the exact word that we say? Induced dipole moment. So induced dipole moment, adar direction eppadi irukum? It will be in the direction of the field. So what will be the direction of the induced dipole moment? It will be in the same direction as the applied field. And adoda value, right, will be proportional to the field strength. Okay, so adoda induced dipole moment value, right, will be proportional to what? Field strength. But enna, like, you know, this assumption, right, may not be true for all the substances. This assumption may not be true for all the substances. But for whichever substances this assumption is correct, we will call these substances as what? Linear isotropic dielectrics in solluvom. So linear edukku varu theriyuma? Because the relation is what? Proportional. So if the induced dipole moment, if the induced dipole moment is proportional to the applied field, it is what? Linear relation dana. So if a material is satisfying that, and isotropic anna, this is telling that it is a uniform. Iso means what? Similar. So you can see all the dipoles are aligned in the same direction, which is the direction of the applied or external field. So if you have a material which is satisfying this kind of an assumption, what do you call that material? As linear isotropic dielectric. Okay va? So linear isotropic dielectric case la the induced dipole moment of the value, right, will be proportional to the external field. Okay, and when we talk about the induced dipole moment, it is like more and more molecules you take, and one molecule will have a dipole moment, right? If you take 1 lakh molecules, other total value will give us some dipole moment. If you take 1 crore, other dipole moment will be giving some higher value. So instead of looking at the total dipole moment value, right, it depends upon what is the number of molecules. What is the number of molecules that are there, adukku mela depend agum. So instead of taking the total value of the induced dipole moment, a better parameter to study is the dipole moment per unit volume. So if you take a unit volume of the substance, right, unit volume means what? You take 1 meter cube volume or 1 unit volume. The unit volume kolla, what is the induced dipole moment per unit volume? So what is the quantity going to be called as? The quantity is going to be called as what? Polarization. What is it called as? Polarization. So what is the polarization? Generally we will represent this by the symbol capital P. We will represent this by the symbol capital P. Dipole moment is small p. Polarization is given by what? Capital T. Paranga, what is the polarization? Polarization is defined as what? The induced dipole moment divided by the volume of the dielectric material. So this polarization is a better quantity to understand the relation between the induced dipole moment and the value of the applied electric field. So for the linear isotropic dielectrics, right, we'll have this kind of relation between the polarization vector and electric field vector, because polarization means what? The total dipole moment per volume dana. It's a vector quantity. Other direction, it will be in the same direction as the dipole moment, which means direction will be what? Polarization vector direction will be same as the external field direction. So for the linear isotropic dielectrics, right, again we will have a relation like what? The polarization vector will be what? Proportional to the electric field, external field, and we can make this into equation by bringing in a constant. What is the constant going to be called as? We will spell it as chi. Okay, so how do you spell it as? Chi. Okay, so chi subscript E, right? What is this? This is basically what? Electrical susceptibility of the dielectric. This chi going to be called as electrical susceptibility of the dielectric medium, which will be a property of the medium. So from medium to medium, although the value will be keep on changing. Okay, wow. So what is this called as? Electrical susceptibility. So now when we go to the magnetism, right, term. So there we will call it as magnetic susceptibility. So what is the chi subscript E? Adhanala we are using chi subscript E. This is what? Electrical susceptibility. Where is it coming? The polarization vector P bar is equal to what? Chi into external field E bar. Okay, wow. So this chi is called as what? Electrical susceptibility, which will be a property of the medium. Okay, so this will indicate what? How the dipoles are aligning. This indicates what? How the dipoles are aligning. If the chi is higher means what? Polarization is higher. It means what? The dipoles are aligning better in the direction of the field. So dipoles are aligning better. If the chi is less means what? the alignment is not proper. So the chi represents what? It represents the property of the dielectric substance, which will tell for a given electric field. Ipo nama different dielectric substance irudhu vechukonga. For all of them we are giving the same electric field, 1 Newton per coulomb. Okay, whichever material is having a higher value of chi, paranga, so all the cases if the electric field is 1 Newton per coulomb vechukonga. Wherever the chi value is higher, for that dielectric, right, the polarization value will be higher. So for whichever dielectric, the chi value is higher, right, for that particular dielectric substance, the polarization value will be higher. So this is what is the behavior of the dielectric substance when we are keeping inside the external field. So external field kulla nama place panna, this is what we are going to observe. The dielectric substance will get net dipole moment. So in the induced dipole moment, a better measurement is what? The polarization vector. Polarization vector is what? The net dipole moment per unit volume. Okay, va? Now we'll also have charge. Initially in the point what is it? We'll get charge. In the dielectric substance also we'll get the charge. Whenever we are keeping the dielectric in the external field, right? External field kulla place panna, we'll get the charge arranged. Eppadi varum paakala. See, whenever we are keeping it inside the external field, what is going to happen? There will be alignment of the dipoles. When the alignment is happening, right, alignment will be like what? The dipoles will be aligned in the direction of the field. So what is happening? In the extreme right side, what is there? In the back, every dipole is giving us the positive. The earth layer you are having a negative charge, and the you have positive charge. So they will cancel. This earth layer one side negative, one side positive, cancel. Earth layer one side negative, one side positive, cancel. So extreme left side negative. So why the charges are coming? Why the charges are coming? Because of the alignment of the dipoles. Okay, so why inside the dipole there is no charge? Because inside the dielectric there is no charge. Because there is an inside the material the positions of positive and negative parts of dipoles, okay, cancel total charge. And why the charge is only on the surface? Surface meladana, it's only on the right side we are having a positive, left side we are having negative. Inside the dielectric there is no charge. Why? Because for one dipole there is a negative part. Adjacent dipole is giving the positive part. So the layers inside, right, we are getting that net charge as what? 0. So we'll see that only on the right side we'll have a positive charge, and left side we are having what? Negative charge. So the charges will be only present on the surface. But idukku difference in case of the conductor, right, why the charges are coming? Because the electrons are moving from one side to other side. The substance the electrons the charging is because of what? Because of the alignment of the dipoles. Okay, va? And since it is because of the alignment of the dipoles, paranga, dipole. So already when you look at dipole, right, so it is not like you have a total positive charge, total negative charge, because these are what? These are all the polar covalent substance. So they will have what? Partial positive and partial negative. So the charge values are what? Generally low. The charge values are what? Generally low. The charge that will get accumulated in the case of the dielectric substance, right, will be comparatively lesser. The conductor case we are getting the complete redistribution of the electrons. We are getting a higher magnitude of the charge. But the dipoles are aligning. We are getting the charges on the surface. But since the dipole itself is having a partial charge only, right? So the charge is coming because of the induction or polarization. These charge values will be comparatively lesser. Okay va? So this is about the net charge of the dielectric in an external field. So point na ulla dielectric substance kulla net charge will be 0. Only on the outer surface you will get the charges, but these charge values also comparatively lesser than the charge that we will see in the case of the conductor. Okay va? Last la paranga, the concept of the induced electric field. Okay, so what will be the induced electric field? So because of the creation of this charges on the surface, so already நம்ம பார்த்திருக்கோம் எப்படி வருதுன்னு சொல்லிட்டு. So if you apply a field towards, பாருங்க, if you apply a field towards the right side means right side என்ன வரும், you will have the positive charge, left side you will get the negative charge. இங்க பாருங்க, so right side there is a positive charge, left side there is a negative charge, but this charge is coming because of what? Polarization. Okay, there will be an electric field that will be from the positive charge side to the negative charge. Paranga, the direction of the electric field is what? It will be opposite to the applied field. So applied field value is E0. The induced field will be what? Opposite. Okay, so the induced field will be what? Opposite in direction. Okay, but induced field engal endu varudhu? Induced field is coming because of polarization dana. Induced field engal endu varudhu? Because of polarization. Polarization means what? The alignment of the dipoles. Adanalada we are getting what? Here the positive charge and in the bakka negative charge. So the induced field will be depending upon the charges on the surfaces dana. The induced field is dependent upon the charges on the surfaces. Paranga, the charges on surface, right, they will depend upon the applied field. And for the case of the linear isoelectric substances, right, polarization will be proportional to what? Applied field. So adanala the charges accumulated, right, will also be proportional to what? Applied field. So நம்ம என்ன சொல்லலாம், இந்த ரெண்டு பாயிண்ட்ஸ் கிளப் பண்ணி what is it that we can say? We can say that the induced field, right, in a way is proportional to applied field. Direction opposite தான் இருக்கும், but induced field will be what? Proportional to applied field. But இங்க என்னன்னா, like the induced field value will be always lesser than the applied field. So paranga, if you try to write it like an equation, so இப்படி எழுதலாம், induced field is equal to what? Some constant, ஏதாவது ஒரு constant value. Let's say we say for example x ன்னு சொல்லலாம். So induced is equal to what? X into the applied field. So here, you know, the x is not the chi, அதுக்கு இதுக்கு நம்ம கன்ஃபியூஸ் ஆகக்கூடாது. This x is what? Some constant. Okay, but இதில் என்ன தெரியுமா, the value of x will be less than 1. The value of x is what? Less than 1. So the net field என்ன வரும் பாருங்க. So what is the net field? Because the applied field and the induced field, they are in opposite direction தானா, means net field will be equal to what? Applied field minus induced field. What is the net field value? Applied field minus induced field. Paranga, net field will be what? The applied field E0 minus induced field. So which is what? E0 minus induced field பதிலா நம்ம என்ன எழுதலாம்? X into E0. பாருங்க, the E0 common எடுத்தா what is it? 1 minus X into E0. என்னது பாருங்க. So the net field is equal to what? 1 minus X into E0. இங்க பாருங்க, this 1 minus X, right, இது எப்படி இருக்கு? It's like a factor. It's like a எப்படி இருக்கு? It's like a factor which is கண்டிப்பா less than 1. ஏன்னா 1ல இருந்து we are subtracting X, right? So அதனால this factor will be what? Less than 1. Okay, so the better way to write it is, instead of having this 1 minus adella, I mean, you know, instead of taking all these things, right, we can write it like a single parameter. So we can write it like, you know, E is equal to, or E net is equal to what? E0 by some constant k. The value of k will be more than 1. The value of k will be what? More than 1. So paranga, instead of multiplying by a factor which is less than 1, we can divide. So E naught can be written as what? E naught by k. What is k? K is a factor which is more than 1. Okay, so instead of multiplying by a factor less than 1, we can divide the E naught value by a factor which is more than 1. So this is just a mathematical way of showing the relation between the net field and applied field. Okay, so in the expression then what is it? In a dielectric substance, right? And the dielectric substance what is it that we can see? The net field will be related to the E naught. E net will be equal to what? E naught by k. The value of k will be what? More than 1. The k value will be what? More than 1. Okay, wow. So this k is going to be called as capital K. So k is going to be called as what? Dielectric constant. K is going to be called as what? Dielectric constant. Left side la electric field, right side la electric field. So adana k will be what? It's a unitless and dimensionless constant. What is this k? That's a unit irukadu, and the dimension also will not be there. So dielectric constant, right? It's a property of the material. Okay, so dielectric constant is also property of the material. Like the susceptibility, electric susceptibility. So on the dielectric constant is also what? It's a property of the material. So we can see what is the relation between the two. There will be relation. Okay, so we'll see what is the relation between the two also. But just like the susceptibility, dielectric constant is also property of the medium. Okay, so in a dielectric substance, net field value will be equal to what? The applied field or the external field E naught divided by k. So k and this is what we call as a dielectric constant. So generally the dielectric constants of some common materials, right? For water it will be approximately some 80. For mica it will be approximately some 6. Like that the dielectric constant value will be changing. If you talk about the extreme case, if you talk about the conductor, for a conductor, right, a conductor what will be the field? Inside the conductor net field level 0 dana, which means the value of k should be what? Infinity. For a conductor k should be what? Infinity. So remember, so for a conductor, right, the dielectric constant value will be what? Very high. It will be what? Infinity. So the more polar, the water is a more polar substance. So dielectric constant value will be higher. Mica is a less polar substance. Adanala the dielectric constant is what? Lesser. So substance is more and more polar means other dielectric constant value will be keep on increasing. Extreme case extreme case the conductor. So conductor the field is what? Net field 0 dana, which means other dielectric constant we have to take it as what? Infinity. Conductor dielectric constant we have to take it as what? Infinity. Okay, wow. So this is about the property of the dielectric constant and how dielectric constant will depend upon the material. So for the polar substances, more polar and the substance or dielectric constant will be what? Higher. Less polar means other dielectric constant will be lesser. Okay, after that the relation paakanu. Okay, and the dielectric constant is something that we are already aware of. Already in the initial topic la relative permittivity patti pesirukkom. So relative permittivity enga varum? If you have the permittivity of the medium, divide this by the permittivity of the vacuum or free space. Adu nama enna solluvom? Relative permittivity nu solluvom. Appadidana. So what is relative permittivity? Permittivity of that particular medium divided by permittivity value of the vacuum or the free space. Other than relative permittivity. So we'll see what is the relation between the dielectric constant and the relative permittivity. What is the relation? If you are in some other medium other than vacuum or free space or air, if you are in some other medium, right? Let us say we are talking about electric field oda function. What is the electric field function? 1 by 4 pi epsilon q by r square. என்னது electric field because of a charge. ஒரு isolated charge எடுத்தா அதுல இருந்து கிரியேட் பண்ண electric field formula என்னது 1 by 4 pi epsilon வரும். Okay, so பாருங்க, what is it? 1 by 4 pi epsilon can be written as what? Epsilon r into epsilon naught. So epsilon r into epsilon naught, okay va, into q by r square. இங்க பாருங்க, இந்த epsilon r மட்டும் தனியா நம்ம வெளியே கொண்டு வரலாம். ரிமைனிங் டேர்ம் என்னது பாருங்க, 1 by 4 pi epsilon naught q by r square தானா. இது என்ன தெரியுமா, இப்போ இந்த மீடியம் பதிலா டேக் வேக்யூம் இல்லைன்னா ஃப்ரீ ஸ்பேஸ், then what is the field? அங்க இருக்கிற field value என்ன? 1 by 4 pi epsilon naught q by r square தானா. மீடியம் பதிலா we take a vacuum or free space வெச்சுக்கோங்க, then what is the field there? 1 by 4 pi epsilon naught q by r square. But அந்த vacuum எடுத்துட்டு we are replacing this with a medium means what is the field here? What is the field here? It is what? இங்க பாருங்க, what is it? இது என்னது E naught தானா. So E naught divided by epsilon r. So field inside a medium is equal to what? E naught, which is the field in the vacuum. Okay, divided by epsilon r. Now we look at the relation that we have seen in case of dielectric. Dielectric case la enna parunga, if you apply a field E naught, apply a field E naught means what? Air or outside la what is the field E naught? And the dielectric substance kulla what is the field you are saying? E net. But what is the E net value? E naught by k dana. Rendu appadiye compare pannunga, because both are telling the same thing, right? Both are telling the same thing, right? What is it? Ingalandu we are talking about the field inside the medium from the dielectric constant oda idilandu. Anganade we are talking about the field inside the medium by using the relative permittivity. Rendu onu dana, because we are talking about the field inside the medium. Okay, so rendu appadi equate panna what you are going to get? E naught cancel aidum. What is it? K is nothing but epsilon r. So in the rendu quantities different kadiyadu. What is it? They both are the same thing. Particularly நம்ம அந்த basic properties ல இருந்து நம்ம பாக்கும்போது we are using this term called as what? Dielectric constant னு சொல்லிட்டு. இதுக்கு முன்னாடியே நம்ம இந்த term பத்தி பேசியிருக்கோம், எங்க? Relative permittivity. Because when you are in a different medium, நான் என்ன சொல்லிருக்கோம், that for every medium there will be a difference in the way they can allow the electric field to propagate. And we said, for any other medium the permittivity value will be different, epsilon kum epsilon naught kum what is the relation? We said the ratio of them will be called as what? Relative permittivity of the medium. So the relative permittivity eppadi varudhu? This is how it is coming, because for different medium, right, the way the polarization happens in the medium will be different. Adanala different mediums are going to have different k values. K is what? Dielectric constant and solala, or we can also say it as what? Relative permittivity. Ena rendu onu da. Okay, so relative permittivity and solidity we will use the word when we are talking it as a ratio between the epsilon and epsilon naught. K we will refer to it when we are talking about the dielectric substances. But rendu onu da. For any medium, right, the value of K is same as what? The value of relative permittivity. So paranga, I can now say the relative permittivity of the mica is what? 6. And the I can say the relative permittivity of the water is what? 80. Appadi. So for whatever the relative permittivity value, the value of the dielectric constant also will be same, and both are same thing. Ingon enna theriyuma paranga, relative permittivity is also what? Adukku or unit irukadu, as well as dimension also will not be there, because it is a ratio. It is what? Ratio between epsilon and epsilon naught. So it will be also what? A unitless and dimensionless quantity. Okay va? So this is the relation between the dielectric constant and relative permittivity. It's not two different quantities, rendu onu da. So relative permittivity we will use the term when we are talking about the permittivity of the medium and permittivity of the vacuum or free space. Anga நம்ம அந்த term யூஸ் பண்ணிருக்கோம். Dielectric constant, we are talking about it when we are looking at the polarization, but both are not two different quantities, rendu unuda. Okay va? Now look at this question. Mica has a dielectric constant 6. What is the dielectric constant of mica? 6. If an applied electric field of 24 Newton per coulomb is taken, what is the net field inside the medium? Straight question dana. So what is it? E naught kuduthirukanga. What is E naught? 24 Newton per coulomb. What is it they're asking? They're asking us the E net. So what is the E net value? E naught by K avladana. So E naught avla 24 Newton per coulomb divided by K avla 6. 6 ones are 6 fours are. What is it? 4 Newton per coulomb. So inside the mica, right? What is the net field inside the mica? It will be what? 4 Newton per coulomb. Okay. So we'll have the questions. Simple questions that, like, we'll have only questions on this particular formula. The formula relating net field and applied field. எது பேஸ் பண்ணி வரும் இந்த ரிலேஷன்? dielectric constant. அவ்வளவுதான். dielectric constant இன்னொரு பேர் என்ன? relative permittivity. ஓகேவா? Now இதுல we have another important thing, especially this can be asked in the questions on force or field or even potential. Force or Coulomb's law force formula based questions, or field formula based questions, or potential formula based questions. Adula we can have this concept called as what? Effective air distance. Effective air distance enna theriyuma? So look at it. Inga parunga, if you have two charges Q1 and Q2, the two charges Q1 and Q2 separated by a distance R entukonga, in a medium having dielectric constant K. So dielectric constant is also same as what? Relative permittivity. Okay va? So these two charges are present in a medium where the dielectric constant is K. Inga parunga, what is the force between the two charges? 1 by 4 pi epsilon, and it's a different medium. Q1 Q2 by R square. Parunga, 1 by 4 pi epsilon ku badala nam enna eludala? Epsilon naught into K. Q1 Q2 by R square. Inga parunga, 1 by 4 pi epsilon naught Q1 Q2 divided by K into R square. இது நம்ம இப்போ கன்வெர்ட் பண்ண போறோம். How we are going to convert? பாருங்க, root K into R the whole square. So K into R square ன்னு சொல்றதுக்கு பதிலா what you are saying? Root K times R the whole square. Now look at it. Okay. So ஏன் நம்ம இந்த effective air distance, ஏன் நம்ம effective air distance சொல்ல தெரியுமா? If the same two charges Q1 and Q2 are present in air ன்னு வெச்சுக்கோங்க, எங்க இருக்க? airல, with a distance between them as root K times R. எங்க இருக்க? where they are present inside the air. What is the distance between the two charges? root K times R. இப்போ நீங்க force formula எழுதுங்க. What is the force between the two charges? 1 by 4 pi epsilon naught. எங்க இருக்க? they are present in air, right? 1 by 4 pi epsilon naught Q1 into Q2 divided by distance square. Distance எவ்வளவு? root KR whole square. பாருங்க, both expressions are same. So if you are having a distance between the charges R in a medium with a dielectric constant K, அது அப்படியே நம்ம ரீப்ளேஸ் பண்ணனும்னா what is it? We can replace the medium with air, but அதுக்கான ஈக்குவலன்ட் டிஸ்டன்ஸ் எவ்வளவு வரும்? எஃபெக்டிவ் ஏர் டிஸ்டன்ஸ் வரும். வாட் இஸ் த எஃபெக்டிவ் ஏர் டிஸ்டன்ஸ் வேல்யூ? root K times R. இது நம்ம ஞாபகம் வச்சுக்கணும். வாட் இஸ் இட்? if you are having a distance R in a medium of dielectric constant K ன்னு வெச்சுக்கோங்க, then if you are replacing that medium with air, then அந்த effective air distance value எவ்வளவு? root K times R. What is the effective air distance? root K times R. Okay, so formula இங்க எழுதலாம். What is the formula? For a distance R in a medium with dielectric constant K, another for a medium with a dielectric constant K, and the medium kulla what is the distance R ன்னு வெச்சுக்கோங்க. Then the effective air distance. Effective air distance anu sonnandi, if you are replacing the medium with air, then the distance has to be changed. How much distance has to be made? It should be made as what? Root k into r. That's the effective air distance. Okay, இதுக்கு என்ன தெரியுமா, லைக் இந்த மாதிரி நமக்கு அப்ளிகேஷன்ஸ் வரல பாருங்க. if you are having two charges, q1 இங்க இருக்கு, q2 இருக்குங்க, the total distance between them is what? r. இங்க பாருங்க, what is the total distance between them? r. but அதுக்குள்ள என்ன, we are not replacing the entire medium with a dielectric. இங்க பாருங்க, if a dielectric medium of dielectric constant k and thickness t is partially filled, fully நம்ம fill பண்றது கிடையாது, only for the and the thickness t மட்டும் we are filling it. Okay, then the effective air separation between the charges becomes, இங்க பாருங்க, so இது எப்படி வருதுன்னு சொல்லிட்டு நம்ம பார்க்கலாம். for this thickness t அங்க actually air கிடையாது. Okay, means what? the total distance r, அதுல இருந்து நம்ம first t subtract பண்ணணும், ஏன்னா அங்க air கிடையாது. Okay, so the normal distance in air, அது என்னது? r minus t. Okay வா, r is the total distance between the two charges. அதுக்கு நடுவுல we are having thickness t which is made up of some other medium. அதனால we have to subtract that t. அப்படியே நம்ம subtract பண்ணணும். அதுக்கப்புறம் இதுக்கு முன்னாடி நம்ம என்ன படிச்சிருக்கோம்? if there is a medium k and the distance that medium is what? இங்க என்னது? what is the distance in this medium? t தானா thickness. the effective air distance, இந்த particular medium ஓட effective air distance எவ்வளவு வரும்? root k times t. அப்படிதானா? அந்த medium ஓட effective air distance எவ்வளவு வரும்? because the thickness is what? t, right? the effective air distance will be what? root k times t. அது நம்ம அப்படியே ஆட் பண்ணணும். so the total air distance எவ்வளவு? r minus t plus root k into t. so பாருங்க, if you have to write the formula for the force between the two charges, in a particular case ல நம்ம force formula எழுத வெச்சுக்கோங்க. what is it? 1 by 4 pi epsilon naught q1 q2 divided by distance square. இங்க என்ன தெரியுமா? we have to put that total air distance. அதோட வேல்யூ என்ன? r minus t plus either t into root k இல்லனா root k into t the whole square. okay, so இப்படி வரும். so this is how we can have. இந்த மாதிரி என்ன தெரியுமா? we can also have problems based upon the field. என்னன்னா like they will give a charge. the charge ல இருந்து we are looking at a field at a point which is the distance r. நடுவுல they will change the medium. change பண்ணா நம்ம என்ன பண்ணணும்? we should always take what is the effective air distance. the total air distance value எடுத்துட்டு we can just write the field formula. அந்த மாதிரி we can also have a questions based on the potential also. so இதுக்கு எல்லாத்துக்கும் என்ன தெரியுமா? we have to calculate what is the effective air distance. அவ்வளவுதான். எப்படி நம்ம effective air distance calculate பண்றது? for a medium, if there is a distance r, அதோட equivalent air distance எவ்வளவு? root k times r. அவ்வளவுதான். okay, so this is the concept of effective air distance. இதை நீங்க ஞாபகம் வச்சுக்கோங்க. this will be very useful while solving problems in NEET. so especially when you are having some questions. ஏன்னா இந்த ஒரு ஐடியா பேஸ் பண்ணி I think we did not get questions. மற்ற காம்படிட்டிவ் எக்ஸாமினேஷன்ல they have asked questions based on this effective air distance formula. but NEET ல மட்டும் they have not asked, touched upon this idea. maybe they can ask some questions in the future. அதனால we should be very careful. ஓகேவா? so this is about the effective air distance and அதோட applications that we can have in the force formula or field formula or the potential formula. ஓகேவா? so this is what we have to cover about the dielectric substances. next class என்னன்னா we will start with the capacitors. okay, so next session we will start with the capacitors, the basic idea of what is the capacitor, how do we have different types of capacitors. ஏன்னா மெயினா நம்ம ஃபோக்கஸ் பண்ண போறது the parallel plate capacitor with equal plate areas. but அது மட்டும் இல்லாம we also have a other set of capacitors also. அது நம்ம பார்க்கலாம். so we'll see what are the different types of capacitors we have, and specifically we have to focus on this parallel plate capacitor with equal plate area. okay, so we will start with the capacitors in the next session.